Let us now study what theoretical knowledge is. After acquiring the empirical knowledge, scientists perceive facts and establishes cause and effect relationships among the observed phenomena. They try to explain and describe the observed events and phenomena, and then they formulate fundamental concepts, derive laws, principles, and generalizations. This type of knowledge is called theoretical knowledge. This knowledge is abstract and portrays a hypothetical picture of the world. This knowledge is based on probability and is not necessarily verifiable. Theoretical knowledge comprises of concepts, conceptual schemes, principles, generalizations, laws, theory, hypothesis. Concepts. According to Nova, concept is a description of a regularity among facts or other concepts. Fact described concept as a concept is an abstraction which is used to classify words, ideas, objects, feelings, skills, etc., which have certain equalities in common. According to NCERT, concepts are systems of classifying information and are generalized ideas. Concepts emerge through process of science. These concepts and processes are interrelated and interdependent. The above definitions of concepts reveals that concepts are broad or generalized idea about an object, symbol or situation. The concept grows along with the intellectual development of the individual and the growth of the individual. For example, the concept of a ceiling fan to a small child is simply that it gives air when switches on. As the child grows, the concept of fan becomes very broad and he will come to know that it is an electronic gadget and how it works on electricity. In a nutshell, it can be said that the fundamental ideas of science change with the passage of time. The characteristics of concepts. Concepts are generalized ideas. Concepts vary from simple to complex. Concepts are formed through varied experiences, including acquisition of factual knowledge. Concepts are facilitated by learning through activity. Concepts may be complete or incomplete. Concepts grow as the children grow. That is, the concept become complete as children grow. A concept is an abstraction to classify words, ideas, feelings which have certain common qualities. Conceptual learning is limited by one's developmental level. A concept is a generalized idea suggested to the individual by object, symbol, or situation. It is not synonym for principle. For example, all living things are composed of cells. Metals are good conductors of heat and electricity. Uses of concepts. Concepts provide a medium for discussion and argument, form a major elements in laws and theories, provides a framework for understanding. Concepts are not eternal and are liable to be changed, modified or replaced on account of further experiences, scientific researches and innovations. Let us now study the conceptual schemes. A conceptual scheme emerges as a consequence of pulling together several major concepts. It is much broader in its coverage. It can be defined as a big idea, a system of facts, principles and concepts which can be organized into a sound learning sequence from simple to complex. So most of the concepts that explain events and processes in science can be grouped into one of the following 7 areas of conceptual understanding. The 7 areas of conceptual understanding are change, interaction, cause and effect, variety and similarity, interdependence, continuity, conservation. Change. The change and everything in it is in a constant state of change. Interaction. Things are constantly interacting with each other, usually causing change. Cause and effect. Changes in substances or organisms can usually be traced to a particular cause. Variety or similarity. All things differ, yet they can be grouped in terms of some similar characteristics or properties. Interdependence. The survival of any living thing is interwoven with other living things and the physical surroundings. Continuity. Life and the forces at work in the environment do not cease. Conservation. Substances can change but do not vanish. Let us study the principles. Principles are formed when generalizations based on many direct observations and demonstrations are made. It is a statement about the behavior of an aspect of nature which has been found to be invariable under the same conditions. So, principles by their nature are generalizations. It is simply a concise statement summarizing what has been observed. When generalizations are formed or based on many direct observations and repeatable demonstrations, they become principle. A principle is considered as a convenient classification of facts into statements. Fundamental truth and explains the relationship between two or more sets of variables. Principle is a rule of action or procedures. Principle is applicable to a given set of circumstances and has value in describing results. Principle is a comprehensive rule or doctrine which furnishes a basis or origin for other theories. Principle is a condensed truth that can be contradicted. Principle can be considered as a brief statement summarizing a number of experimental results which are repeatable. Let us study the characteristics of principles. It is a statement of relationship. It is formed on the basis of reasoning. It usually has some significant applications. It is always a fact. It is illustrated. It is not a definition. The principle is the statement of relationship frequently caused in nature between two facts. Principles differ from concepts. In that principles state some kind of relationships between two or more concepts, objects or events. Concepts are not principles, but principles may have concepts in them. It is significant in its application. It should be proved. It can be illustrated and it should not be definition. Example: Archimedes' principle, Newton's law of motion. Let us now study generalization. Generalization helps in deriving conclusions from scientific facts. Facts, concepts, and generalizations are interrelated and interdependent. Facts give rise to concepts, and when facts and concepts are classified based on some scientific processes, they give rise to generalization. Example: any object which is thrown up in the air will come back to the ground due to gravitational force acting on it. Thus, the process of repeated experiences through which a valid conclusion is in the form of a principle or law by adopting inductive approach is usually referred to as generalization. All metals get expanded after heating. The process of evaporation takes place on heating water. The process of science through which generalization could be made are observation, classification, communication, prediction, and experimentation. Let us now understand what law is. A scientific law may be defined as a factual statement of what always happens in certain circumstances, or it can be defined as a theory which has been exhaustively tested and found to be valid with few or no exceptional cases. According to Encyclopedia America, a scientific law is a general statement that purposes to describe some general facts or regularity of the universe. Scientific facts and concepts, after proper generalization and further verification, may be accepted as a scientific law in science. Thus, a verified generalization is considered as a scientific law. A hypothesis verified on the basis of cause and effect relationship, proper experimentation, valid observation, and tested application is accepted as a scientific law. Example: Mendel's law of heredity, laws of learning. So, a scientific law is a description of a natural phenomena or principle that invariably holds true under scientific or specific conditions and will occur under certain circumstances. A scientific law is a statement that is true and valid for all times and at all places in the universe. Definitions of law vary with different scientists. A law is a set of observed regularities expressed in a concise verbal or mathematical statement, says Crimley. A law is an empirical generalization, a statement of biological principle that appears to be without exception at the time it is made and has become consolidated by repeated successful testing rules, says Lincoln. Characteristics of law. Scientific laws, although based on observational evidence, go beyond that evidence. Laws are descriptive. Laws generally are based on the laws of broader scope. Let us now understand what theory is. A theory is a proposed explanation of a set of conditions or events unproved but usually supported by strong evidences. Thus, theory represents a well-organized system in itself. This system comprises of the related scientific facts, concepts, generalized conclusions, and laws as different subsystems operating in a very interrelated and interdependent way. What is hypothesis? A hypothesis is a proposition that is empirically testable, said Bailey. Hypothesis is a proposition stated in a testable form which predicts a particular relationship between two or more variables. It is also described as tentative statement accessing a relationship between certain facts. Just as the concepts are the building blocks of propositions, propositions are the building blocks of theories. Subtypes of propositions include hypothesis, empirical generalization, postulates, and theorems. It is a tentative assumption drawn from knowledge and theory which is used as a guide in the investigation of other facts and themes that are yet known. Example: there will be significant differences between the characteristics of oxygen and sulfur.